like to talk about some derivatives, okay? Derivatives of exponential functions. So the basic rules are these two. E to the x is its own derivative. Any other base will differentiate as the original exponential expression times the natural log of the base. Now, if a was to this rule does work. This rule does work for a equals e. Okay, but e to the x would differentiate under this rule as e to the x times the natural log of e. Natural log of e is 1. So e to the x times 1 would give me e to the x. Okay, so that's the reason why these two rules are explained differently. Okay, so example 1. We're looking for our derivatives. So f prime of x is, well, 93.2, and the derivative of e to the x is e to the x. Okay? Now, example 2, I have f of x equals 93.2 to the x power itself. This is the rule that I would follow for that situation. So that's going to be f prime of x equals 93.2 to the x times the natural log of the base. And that's it. Okay? So, example 3. F of x equals e to the x to the 11th plus 25. F prime of x would equal e to the x to the 11th plus 25 times the derivative of the exponent. So that'd be 11 x to the 10th. Okay, so f prime of x would ultimately equal 11 x to the 10th times e, and then the original exponent would stay as is. Okay, that's a pattern that I'm hoping everybody will quickly recognize, is that the original exponential expressions always stay. Other things get tacked on, but the exponent might get tacked on, but the exponential expressions always stay. So for instance, example 4. Okay, 1,000 to the x cubed minus 15th power. F of x. So example 4. F of x equals 1,000 times x cubed minus 15. Well, that's going to be f prime of x equals, you're going to have the original exponential expression and then you're going to have the natural log of your base, so natural log of 1,000 times the derivative of whatever this was. So that'd be 3x squared. So f prime of x could be written as 3x squared times 1,000 x to the 3rd minus 15 as an exponent. I'll move it down for clarity's purposes. So f prime of x would equal, I'll put that in the front, and then I'll put that in the middle, and I'll end it with the logarithm of my base. Natural log of 1,000. Okay. You'd like to review that, hit your pause button. Otherwise, I'm going to erase the board and move on. Example 5. F of x equals (40) e to the x to the 5th minus 9. F prime of x will equal 40 times e x to the 5th minus 9 times the derivative. So that would be 5x to the 4th. So f prime of x will equal 200 x to the 4th e x to the 5th minus 9. Here's another one. Here's another one. Example 6. F of x equals 900 e to the point 0.6 x power. F prime of x would equal 900 times 0.06 e to the 0.06. Well, let me do it the other way, okay? Well, I'll do it a different way. So I'll follow the chain rule way first. So I'll be 900 times e to the 0.06 x power times the derivative of your exponent times 0.06. Okay? That would give me 0.06 times 900 is 54. And that's going to be e to the 0.06 x power. Okay? Okay. So I have a couple more. I'm going to do them one at a time. So this one right here is going to follow this rule right here because the base is e. So f prime of x will equal 15 and your original exponential expression. Times the derivative of the exponent. So that's going to be 9x to the 8th minus 2x plus 13. Now, I'm going to rearrange this so that the exponential expression is last, and I'm also going to leave it factored. So I'll have f prime of x equals 15 times this and then the exponential expression goes last. Like so. Okay? Now example 8 is going to follow this rule right here. Okay? So f prime of x will equal the original exponential expression, 111 times 83 to the x minus 47 times the natural log of the base, 111. Okay? Times the derivative of the exponent. So that would be, the derivative of this is just 83. Okay, so f prime of x is generally what they're going to, what some people do is they'll put the regular number first, the derivative of the exponent first, then they'll put the original exponential expression in the middle. This is the way I normally write it, to be honest. And then times 10 times the natural log of your base. Okay? That is normally how I write it. Okay? But as long as everything is there, it's accurate. Yeah, I'm going to make this the same size as everything else. Okay? So as long as you have the original exponential expression, so the natural log of your base, and the derivative of your exponent, it's accurate. All right? And I am going to stop.